Hello, so here we are looking at k-means clustering. So k-means clustering is a very popular unsupervised learning machine learning algorithm. So this is one of the clustering techniques, as we know, and as we have discussed various type of clustering. So basically most two related clustering algorithms are k-means and fuzzy c-means. The only difference between k-means and fuzzy c-means that some points in k-means only belong to a single cluster, while in fuzzy c-means they may belong to one or more clusters. So before we move ahead, let's look at the content of what we are looking at. First one, we'll be looking at the introduction, then some applications and intuition behind that, and then choosing values of k that we have already seen, and elbow method and all. Next we'll be doing data processing, ADA, and different types of models which we can run using k-means, and see the efficiency with each hyperparameter tuning, and the last we'll be comparing that how it's going to work. Okay, so first we'll be looking at the introduction. So the introduction basically is that before that this is a cluster of input. As we know, in the k-means we have random data and without any label. So we just want to group or cluster them based on their similar characteristics. Let's say this is our input, and after passing it through the k-means model, this will be clustered in this way that there are three clusters being formed. So what is k here? K here is the number of clusters we want to form, and that can be found with the help of elbow method that we'll look ahead. Next, we'll be looking at the applications. So applications basically image segmentation, as I have already uh, described that if we have random inputs, for example, of animals like dog, cat, or cows, etc. So what k-means clustering model will be doing, it will be clustering them on the basis of most related features of them. For example, a dog may be similar to another dog, and a cat may be similar to another cat, and dissimilar features will be segmented in the same way. So that's the basic intuition behind the k-means and applications. Okay, another thing is like anomaly detection, species clustering, customer segmentation clustering, languages. Obviously that some kind of customers may be segmented from other in many ways. Okay, based on their behavior and features, that how is their buying pattern or shopping pattern. Okay, next it's k-means clustering intuition. So intuition is very simple. We just decide the k, and we'll assign centroids, and based on the distance we'll assign the points to a particular cluster, and we'll try to update the cluster then. And then after that, what we'll be doing, we'll be again repeating this cycle again and again, so until and unless the centroids gets stops changing. Okay, and next is centroid update. Is very simple. We just take the average of all the elements in the center that cluster, and the average of all the elements will giving us the centroid. Okay, this you can see this for now. The cluster is here, centroid, and after the updation it will come here, and then after the updating the centroid, we again repeat this process until it converges. So choosing the value of k is the number of clusters. So one method we have already seen that is one of the elbow method. So elbow method is meant by nothing but there is a WSS, like within squared sum method formula, which is used to plot the graph between k and WSS. So whatever the knee point in the that graph, that will be the optimum value of k. So that we are going to look, and that we have already looked actually. So there is nothing much to discuss about it. Next, we'll be directly moving to the implementation of k-means. So let's see what we are actually going to look. So this is our input before we start running our whatever analysis and algorithm part. So this is a data set from Facebook, and this is the live seller UCI report. So there are certain features, status type, status, and also other features like numbers of reaction, number of comments, number of shares, number of likes. So there are some statistical features. We want to cluster them based on the similar features. So let's see how we will be doing that. So first let me run this cell. we are just importing NumPy, Pandas, Matplotlib, and Seaborn. These are just NumPy is for array processing and linear data. Pandas, obviously used for reading CSV and playing with the data frame. And Matplotlib and Seaborn are used for visualization purpose. Next, we are just setting the path to the Kaggle. Kaggle is a very helpful platform for running machine learning algorithms. We also have added accelerators here and much more features. Also, we can randomly add our data from any of the collections of the Kaggle. So there are various available collections. You can just go and search Facebook dataset. It will be giving you many Facebook datasets. Okay, so that's how it's going to work. Next, we'll be just doing this for ignoring warnings. The last is we are going is what? Just reading the dataset and storing it in the variable df. Now, then the most important and upcoming step is we'll be performing exploratory data analysis. Sorry. So we'll be first looking how big is our data. So it's having 7050 data entries and 16 columns. So 16 features basically. So let's see that how our data set looks like. We run this, and this is the status ID, status type, status for when the particular post is published. Okay, and the number of reaction, number of comments, shares, likes, loves, wows. It's just basically the type of reaction which is given. So this is the total, and this is kind of the number of likes and all. That's obviously it's gonna sum to this number of reactions. And these are some other columns. These are NaN values. So let's see that what they contains, and according to that we'll be doing some data processing. So data processing in that not much of a deal. Okay, so after just running df.info, we found that these all are not null above up to number of angries, and these are object or either integer. These obviously likes, shares, and these are integers, and apart from that status ID, type, and published are objects. Last four columns are non-null, and there are zero basically entries and float. So we can just go and run check for the missing values by df.sum, and we found that last four columns are basically null. So we should drop them. It's a very common practice to drop the columns which are having more null values, and in this case there are all null values. So that we run. Now if we again run, then these all four columns are removed. Now we'll run df.describe, and now it looks pretty much good. Df.describe is used for finding out the count, mean, standard deviation, minimum and maximum values, and obviously 25 percentile, 50 percentile, and 75 percentile values, so that we can remove them according to the need if there are some outliers and all. Okay, now we already know that there are three categorical variables in the dataset. These are this status ID, status type, status published. So let's try and explore them. So let's see how many unique values are there. It seems there are a lot of unique values in the status ID, and if we see there are 6,997 status IDs. So the total number of instances of dataset is 7050. So it's approximately all the values are unique. So this is not the variable that we can use, so we have to drop it basically. Let's see the date published, and let's see the how many published data. So they are also so much, so we cannot use this also. Let's see what our status type. So status type is length 4, so we can see there are 4 status types like video, photo, link, and status. So obviously we can use and obviously we can drop status ID and status published because they are so almost unique for every entry. We'll drop them, and now let's see df.info. So now we have these columns remaining. There are 10 columns remaining after this clearing. If we see, there are these are the columns we are left with. Now status type is object type, so we have to convert it into integer type because we don't want our machine to feed with the object data type. So we'll just we'll just have X as our data frame and Y as our status type. So because this that we have left here, so we'll be using label encoder for encoding that X, that status, because we have 4 entries, so we can just randomly assign them 0 1 2 3 4 0 1 2 3 based on their type, as so it will become a numerical feature. So we have label encoder here. So after running label encoder, gcx.info, now these are all integers, and status type has also become integer. So if I see x.head, so now it's 3 1 3. So for example, it has assigned 1 to photo, 2 to videos, 0 to links. So that's how it has worked. Now which we'll do feature scaling. So we'll take columns in one variable, and then we'll be using min max scalar. It will be imported from SQL. We do feature scaling to enhance the accuracy of our the calculation, because if the values are so small, then it will have a small impact on the model. So we do feature scaling so that it's become easy to calculate all the mathematical things. So we'll be using mass scaling, and then we'll be having this. And if we see the uh, our data set now, then it has scaled it down so that our calculations become simple. Now the next, we are looking at different models, kind of variations of models of k-means, and see and compare that how it's gonna affect the performance of the model. So let's first look at the k-means model with 2 clusters. So we are just importing k-means from the sklearn cluster, and number of cluster, let's say 2. That's basically the k value, a random state 0. Let's run k-means.flush, and now let's see the cluster centers of this model. So these are all the cluster centers. Okay, now let's see inertia. So this is the inertia of the model, and now we have to see that quality of weak qualification of model. So let's count them with this formula. Like we have to compare y with the labels, and we are just importing labels from k-means.label, and then it will be printing that the number of correct labels and the number of labels, total number labels. So 63 out of 7050 were correctly labeled. Okay, so now if we look at the accuracy, it's not that great. It's 0.01. So it's a weak classification. So now we have to find the optimal value of k, because here we just randomly took 2, and that doesn't classify them as good. So we have to find the optimal value of k so that we can train our model nicely. So we'll be using albo method. So this is the formula for albo method. We'll be calculating k-means for different clusters. We are trying it from 1 to 11, and whichever will be the best way, then we'll be seeing which value to use. So we'll plot the different values of k and their inertia. Inertia is basically WSS. So it is running, and this here in this graph we can see that at there is a kink at k equals to 2. So and as we increase this up to 4 or 5 or 6, then this becomes stable. So this seems to be our elbow here. So because in WSS there is this seems to be our elbow, but it's trying to gradually decrease slow and slow. So first let's try with the value of k equals to 2, then we'll try to change it. So that we have already done actually. So the accuracy is 0.1. Now let's try it with n equals to 3 and see the accuracy has not increased that much, but it has become at least 2%. Now if k equals to 4, it has 62% of accuracy. So there is a rapid increase. You can see there is a rapid increase from 2% to 62% now. So this is how we have done things. Let's try to duplicate this cell and see what happens if we do with k equals to 5. So if we do with k equals to 5, then let's see what's the accuracy. So accuracy is again decreased. So here we can see that with k equals to 4 here in the model, this is the stability point. So after that it's again decreasing. So let's try with one more thing. Let's say do it with k equals to 6 and see what's the accuracy here. So if we go with 6 and the accuracy is still down. So the conclusion is that testing the different values of k may result in different accuracies. So we have to find it with the help of algo methods, and we'll be trying with those kind of value. So you can also try various models with this resources I'll be providing them. So thank you. That's all for the k-means question.